Hello again. Thanks for joining us. This is a Q&A episode of Space Nuts where we answer astronomy and space science questions from our audience. Today, David wants to know about Mars meteor showers. Penny is asking about fly-through missions for Saturn and Jupiter. That could be messy. Andy is asking about the gravitational effect of Jupiter on its moons, particularly Europa. And Duncan wants to talk about alien civilizations. We will deal with all of that and more on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
This is Fred Watson's favourite segment. He's back again for more. Professor Fred Watson, astronomer at large. Hello.
Hello, Andrew. How are you?
I am quite well. It's been a long time, like, I don't know, 2 or 3 minutes.
Hope nobody's guessed that we record these in pairs, but never mind.
If they haven't figured it out by now, they probably never will.
That's right.
I'm pretty sure most people know how it works. I mean, they just have to look at the shirts we're wearing every week. That's if they do it on the YouTube channel. Well, I don't know if they put the video on anymore because it could be a bit of a turn off. So I don't know. Anyway. All is well with you, I trust?
It is, thank you. Yes, all good.
I already knew the answer, but we have to ask because, this is...
Just to be polite.
Yes, that's it. Exactly. Why don't we try and answer some questions?
Oh, all right, if you must.
Well, you do it. I'm just going to push them in there. Let's go to our first question that comes from David.
David Thompson here from Oatley Spring in the UK. Back to Mars. As a child of the 50s and 60s, reading the comics at the time, there was always a risk of meteor showers. I'm just wondering, given that Mars' atmosphere is not as dense as the Earth's, whether smaller meteorites would be able to hit the surface of Mars and be a real hazard to anybody putting a house there. Find the podcast absolutely amazing. Everybody have a great day. Bye.
Thank you, David. Thanks for those kind words. I'm glad you're enjoying the podcast. So we're back to Mars. I didn't push him there. I didn't. Everyone knows I love Mars, but... Yeah, meteor showers. He brings up an interesting point. It's got a much less significant atmosphere than Earth. So does that mean smaller things can get through?
It does. Yeah, it does. David's absolutely right. I'm delighted we've got a listener in Oatley Spring. I used to drive past there very, very frequently. It's between Durham and Sunderland in the north of England, and I was a very, very regular user of the A1M, which goes right past Oatley Spring. And it's lovely to hear your voice, David, and hear that lovely North Durham accent there. The answer is yes. So because the atmosphere, the atmospheric pressure on Mars is, I think it's 0.6% of our atmospheric pressure, which means that meteorites coming in are going to have a lot less resistance. We know of meteorites on Mars. Many have been identified by both Curiosity and Perseverance, usually by their colour, but both those rovers were equipped with laser zappers that could give us an idea of their content, and some of those meteorites have been found to be metallic. So meteorites on Mars are something that happens, and yes, there's probably a higher risk of damage from an incoming meteorite on Mars than on Earth, because the likelihood is that their terminal velocity, the sort of final velocity after they've passed through the atmosphere, will be much higher than it will be on Earth just because of that lower pressure. And so, yes, meteorite protection might turn out to be quite an important aspect of putting humans on Mars. We haven't had any reports of, there's how many rovers have been on Mars now? I can think of 1, 2, 3, 4, 5, 6. at least 6, probably more like 7 or 8. They are, Andrew's Googling it as we speak.
Yeah. Six rovers: Sojourner, Spirit, Opportunity, Curiosity, Perseverance, and Zhurong, the Chinese mission.
The Chinese one, that's right. Yeah, so I did get the right answer, 6.
Yeah.
It's so none of those, as to the best of our knowledge, has suffered any kind of meteoritic impact. So at least so far so good in terms of our understanding of the meteorite hazard on Mars. But a good question to raise, David, and always gives us a chance to talk about Mars.
He did ask about the danger to housing on Mars. They probably won't build houses on Mars like they do on Earth, and because of the radiation issues, they're probably going to have to go underground, which would protect them from anything like that. But there will be surface something or other there one day.
Surface infrastructure.
Yeah, perhaps domes, that they could be susceptible, maybe.
Yeah, it looks like, I mean, what we imagine is something like White Cliffs in western New South Wales, where people live underground.
They do.
And that's just to get out of the heat. So
that's radiation.
Yes, it is. Solar radiation, that's right. Yeah, indeed.
Yeah. Sort of another question. Here it is. We are constantly monitoring for big objects that could be threatening to Earth, things that could destroy cities or regions or, God forbid, the planet itself as we know it. What about Mars? Do we keep an eye on anything that might hit that?
So, yes, to some extent, if you can identify near-Earth objects and look at their orbits, you would certainly find out from the analysis very quickly if there was any risk of one of those hitting the planet Mars. But there's probably many small objects in the vicinity of Mars, because it's closer to the asteroid belt than we are, which are undetectable from the distance of Earth. Objects that might even be as big as Phobos, Mars's biggest moon. We would be able to detect that from Earth quite easily, but as we obviously can, it was discovered in the 1800s. But, if you had something that was only a few tens of meters across, which could pose a hazard to houses on Mars, that would be hard to detect from the distance of Earth, unless it was also a near-Earth object, so it was coming closer to our telescopes.
Yeah, there'd be nothing much we could do about a big thing hitting Mars anyway, is there? Or there'd be a good experiment if we wanted to test our capabilities.
Well, yeah, that's right. If there was, the bigger ones are the ones that we know more about because they're easier to see. If something like that was looking as though it might collide with Mars, yes, it might be a good time to test out the theories that were put into place with the DART mission a few years ago.
Yeah.
See whether it'll actually work on something a bit bigger than that.
Well, one can only wonder, but hopefully we don't ever have to put it to the test for ourselves. But you just never know. There's always something going on out there. There's so much stuff bumping into it. There's something else out there. It's only a matter of time before one of them careens into our sector and becomes a potential threat. Although we seem to be finding them more and more now, don't we, Fred?
With and that's the good news part of this story. Yeah. Two good news sides of this story. One is that the big ones are the easiest to find, and the other is that we've been finding these things now for the last 40 years and have a good idea of what the Earth's environment's like.
Yep. Great to hear from you, David. Great question, and thanks for sending it in. Our next question comes from Penny. It's a short, quick one. I think I know where this one might go too in terms of an answer. As Saturn and Jupiter are gas giants, are there any plans to fly a spacecraft through the middle of one or both of them? Interesting question, Penny. I do recall when you're talking about comet or asteroid impacts, the impact with Jupiter many, many years ago that we almost got footage of. It was just not quite the right angle, but we did see the aftermath of it.
That's Schumacher-Levy.
Yes, that's the one.
Hit Jupiter back in, can't remember what year, 94, I think it might have been. So The issue is that the gas giant aspect of these planets is really just their outer envelope that's gassy. And we don't really know what's underneath that. The likelihood is there will be a solid core there. It may be rocky. Some have suggested that it will be made of metallic hydrogen, which is hydrogen in a very unusual form. So you've got a core of something called metallic hydrogen. So flying through is not anything that's planned because it would be impossible. But even if these gas giants were sort of gaseous all the way through, it still would be a very hard thing to achieve because you're entering an atmosphere. You'd have to slow the spacecraft down enormously in order to prevent it from just melting by friction with the atmosphere, which is what happened to Cassini. Cassini was plunged into Saturn's atmosphere at the end of its mission in 2017. It didn't burn up because there's no oxygen in Saturn's atmosphere, but the friction made it melt, basically. It just melted and fell to pieces. In fact, NASA produced some real tearjerker footage of what that might have looked like, which we saw often at the end of the Cassini mission. This thing which had performed valiantly for the previous 13 years and done a marvelous job at revolutionizing our knowledge, not just of Saturn and its rings and moons, but also the way planets form and things like that. This footage of Cassini hitting the top of Saturn's atmosphere and having its antennas ripped off and eventually just melting into becoming part of the atoms of the atmosphere of Saturn. And that is, any mission to try and penetrate down through the atmosphere would struggle because of the rapid increase in density, the fact that you've got to slow the spacecraft down in order to stop it just burning up by friction. I think one of the Jupiter missions, I can't remember which one, might have been Galileo, actually sensed as it hits Jupiter's atmosphere to burn up again or to melt. I think there were sensors on board that were giving us some readings of what the conditions were like.
Yeah. I think the other big problem would be pressure, wouldn't it? If you tried to fly through.
Right. Yeah. So the pressure just goes up probably exponentially at some level.
Yeah. And Penny might be interested to know that there are some missions slated for the near future. Europa Clipper, which will launch it's already launched. Should arrive in 2030. There's the JUICE mission, which launched in 2023, which arrives in 2031, and Dragonfly, with the helicopter.
Off to Titan.
Yeah, will launch in 2028. So they're more interested in some of the moons around those gas giants. But yes, they are fascinating. And of course, we're most interested in Europa Clipper because we want to know if anything's living in the ocean. And maybe there is, maybe there isn't. Who knows? It could just be made of jelly. We don't really know. Although the JUICE mission's more likely to figure all that out. Boom, boom. Thank you, Penny. Lovely to hear from you. This is Space Nuts Q&A edition with Andrew Dunkley and Professor Fred Watson. Let's take a break from the show to tell you about our sponsor, NordVPN. Now, if you've ever felt like your online privacy is slipping through the cracks, then you're not alone. Hackers, scammers, harvesters, they're all out there trying to get your private info, whether that's your passwords or your personal details to sell on the dark web or to use themselves to access your bank accounts, credit card details, and who knows what else. But you can protect yourself with NordVPN. You can take control at home or more importantly, when you're out in public using free Wi-Fi. Right now, using the exclusive Space Nuts offer, you can receive 4 extra months for free on a NordVPN.com plan. NordVPN encrypts your internet connection, hides your IP address, and offers access to over 7,700 servers around the world. Plus, with features like Threat Protection Pro, MeshNet, ultra-fast speeds via Nord links, your digital life stays private and efficient. So don't miss out. Visit nordvpn.com/spacenuts and enter the code spacenuts to claim this deal. Remember, there's a 30-day money-back guarantee, so it's risk-free to try. Stay safe, stay private, and browse with confidence. That's nordvpn.com/spacenuts.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
And speaking of Europa and Jupiter, we've got a question now from Andy.
This is Andy, the train driver from London. Just got a question about Europa. I know Europa erupts because it's being sort of squeezed by the gravity of Jupiter. But what I don't understand is if Europa is being affected by Jupiter's gravity, why is it not just being pulled closer to Jupiter? I thought gravity pulls things down, like when you throw a ball in the air, gravity pulls it back down. I don't understand how Europa is being squeezed. That suggests to me that it's being affected by gravity from all directions. So I squeeze it like you could squeeze a tennis ball. Maybe you can shed some light on this, or tell me that I'm barking up the wrong tree. Anyway, thanks for the podcast, guys. Really interesting. And see you on the next one.
It's Geordie's job to bark up the wrong tree, but
Nicely done, Andrew. I like
yeah, your point is well taken, Andy. It's not just Europa, though. There are several moons orbiting the gas giants that do get that squeeze effect. Titan, I think, is one of them, and probably all of them to some degree. But Europa, yeah, it's in a difficult position. It's a good question, though. Why don't they just get sucked in? Like our moon doesn't, but we're not a gas giant.
No, the same thing happens to our moon, though. It's actually probably, I think the moon that Andy's thinking of is Io, which is the innermost of the moons, the big 4 moons of Jupiter, and it is the one that gets the most squeezing and squashing because of its proximity to Jupiter. Europa probably also has the same phenomenon, and there may be eruptions of it on Europa that possibly a bit like Enceladus, where you've got stuff streaming out through the cracks in the ice. But the genuine volcanic eruptions, which they really are, it's hot lava, is what take place on Io, the innermost of those moons. So the way to understand this is to recognize that if you've got an object in a very strong gravitational field, first of all, let me just clarify the reason why objects in orbit around other objects don't just get pulled in. They are getting pulled in, but they've got a forward motion that compensates for the pull. So basically the motion of the object through space is what balances out the gravity of a giant like Jupiter. And so the greater the gravity of a planet, the faster its satellites have to orbit in order not to fall in. And so that's the mechanism that stops these things just immediately being sucked in to Jupiter. They're already moving, and that comes about. Why are they moving? Because they were formed that way, with the way the planets and their satellites evolved, the way they formed. They're basically swirling around right from the start, and that swirling motion is what stops, which is fossilized in the planets themselves and the moons of the planets, and stops them falling into their parent object. But the squeezing and squashing comes from what we call the tidal effect, and it is actually exactly the same thing that gives rise to tides on the Earth. But let's concentrate for a minute on Io. Here's this little world right next to gas giant Jupiter. One side of Io is feeling the gravitational pull of Jupiter. The other side is as well, but it's feeling slightly less because it's further away, because the gravitational pull falls off as the distance squared, 1 over the distance squared. So further on the farther side of Io from Jupiter, it's going to feel less force, and that is what contributes to this tension that there is, and basically elongates the planet slightly in the direction of Jupiter. Now, why we talk about squashing and squeezing is that throughout the orbit of Io, which is not a planet, it's a satellite, but around the orbit of Io, as it goes around, is not circular. So sometimes that force is greater than others. That tension that's trying to pull it apart is greater than at other times. And basically, it's that squashing, stretching really is the best word for it, as it goes round Jupiter. That change in the stretch force that's being applied is what generates the heat that causes these eruptions to continually take place. So, and that's called the tidal effect, the fact that one side of a body feels a different gravitational force from the other. It's what makes us susceptible, if we fall into a black hole, to spaghettification. Spaghettification is just a nicer word than tidal effect.
Yeah. So you've got a real combination of factors.
Yeah, that's right.
You've got the gravitational effect. You've got orbital dynamics.
Yep.
All sort of coinciding to keep these things from falling into the planet, but there's a tug of war going on.
Yeah.
I saw a really good demonstration online, probably 3 or 4 weeks ago, on how the tides work on Earth. And of course, most people, and I must confess guilt here, assume that the moon causes the water to rise and then fall, but it's not. It's the fact that the Earth is rotating, the moon is orbiting, and there's always a wave. It's just always there. And it's just that when the moon reaches your vicinity, that lump of water comes up.
Yeah.
And goes down again. It's not the water so much rising. It's always risen in proximity to the moon. Am I right?
You are. You're partly right, because it's a bit more.
I knew I missed something.
Yeah, that doesn't explain the bulge on the other side, because as you know, you get a high tide every 12 hours, not every 24 hours, and that's because again, it's the tidal effect. So the moon's pulling on the ocean on the near side. It's also pulling on the Earth itself, and that leaves behind the water on the other side. So you get a bulge on each side. That's how it works.
Fascinating. Yeah, it's worth looking up that demo. I didn't read the fine print, obviously, but that makes sense. So the water's being pulled, Earth's sort of dragging with it, and then the water's being left behind on the other side. So you've got two bulges.
Two bulges, exactly so.
It's fascinating.
So,
and that's basically what's happening to all these moons in various ways. If they haven't got water, something else is being...
Well, that's right. It's the rock.
Around.
The rock does it as well. The same is true on Earth. The rock goes up and down as well. I've got a question for Andy, though. If he's ever getting back to us, I'd like to know what sort of trains he drives.
Yeah.
Because, I'm a bit of a train nerd myself. Train drivers are my heroes.
Yeah, I live next door to a retired train driver. So, yeah. But when we flew into Dubbo the other day, I looked down at the rail maintenance facility. It's a brand new system facility that's just been built in Dubbo. And they're fitting out all the new regional trains. And you can see them all lined up, bright red, all getting ready to go. They're putting all the furniture in them and the Wi-Fi systems. And, they'll be rolled out pretty soon. Not exactly sure when, but the plan is soon. That's the answer to the question officially. But,
Have you ridden on new metro trains here in Sydney?
Yes, I have. Yes.
So you'll know that they drive at 100 kilometres an hour with no driver. You can stand at the front, look out the front window and pretend you're driving it.
Yeah. Well, I've done that in a taxi in San Francisco.
Oh, yes, you have.
Driverless taxi.
Driverless taxi.
That's next level. That's just amazing.
But yeah.
Pretty incredible stuff. Thanks, Andy. Really enjoyed that question. And if you want to tell us what sort of train you drive, send us another message. We'd love to find out.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Space Nuts.
Our final question today, Fred, comes from Duncan. He said, I've heard that a group of astrophysicists have calculated that there are an estimated 1,000 alien civilizations spread across the Milky Way. But the Milky Way is 100,000 light years across. How far away would an advanced civilization have to be, in practical terms, to be uncontactable? In other words, are we realistically, given the distances involved, effectively alone?
Yes is the answer.
Yeah.
And it's not just about the distance, it's also about the time. Because 1,000 civilizations in a galaxy that's 12 billion years old, they might well have turned up and gone long ago or still be in the future.
Yeah, we
And there's
can't
actually-
assume that we all coexist.
That's right. And we probably don't. There's actually a really nice piece. Now, let me see if I can find it to direct Duncan to it. It's on one of the science media came in today. So actually, I think where is it? Sorry, I've lost it. It's basically a summary of thinking by the likes of Richard Feynman and other great minds. And the bottom line is it's exactly what I've been saying. It's not just the distances, it's the time that the era in which you live. And it's very unlikely that we'd find communicable civilizations within the same time zone that we're living in, if I can put it that way. It's actually it is on the brighter side of news. And the headline is a really very, very thoughtful article, well worth a read. Interstellar travel is impossible and aliens haven't visited the Earth, physicists say. And it's because the laws of physics basically make any kind of travel or even communication extremely difficult. The laws of physics are very rigid, worth having a look at.
Yeah, indeed. Although there's this new book that I know that's been written that kind of is counter to all that, but you can do that in science fiction.
Quite so.
Yeah.
That's why it's called science fiction.
Yes, that's what it is. By way of example, though, if I may, Duncan, if you were to be aware of an advanced communicative civilization on a rocky planet orbiting Alpha Centauri A, for example, and you sent them a message, it would take, I'm just trying to remember, 4.37 years to get there. And that means a return message, if they answered you immediately, would mean that you would not get a reply for 8.74 years. Yep, give or take. But let's round that out to a decade, because you know what the bureaucracy is like around Alpha Centauri. They're not going to, they're going to take a couple of years to figure out what they want to say. But that's the reality of it, isn't it? And that's our nearest potential neighbour.
It's true. And I mean, the point that this article makes is, we live in a bubble of radio radiation, which are all the transmissions from Earth. That's now basically 100 light years in radius, because we've been sending radio transmissions for about 100 years. And all right, what's that? 100 divided by, it's 1,000th of the diameter of the galaxy. And so, it's hardly any distance at all. So, yeah, it's in a way, an uncomfortable reality. To all intents and purposes, we're alone. We're uncontactable. We are alone. That has its good side, because we're unlikely to be picked on by any voracious aliens. But,
yeah. I think we've got to be realistic about it. Even if there are 1,000 alien civilizations with advanced technology in our galaxy, we are probably never going to be in a position to communicate with them, and certainly not be able to travel to them in any meaningful way. And so, even if we're not alone, we are alone.
Yes, that's right. Exactly. That 1,000 civilizations, maybe 500 of them have been and gone, and 500 of them are yet to evolve.
Do you concur with that estimation, or you don't think it's?
I have seen similar figures being quoted. Not that there's that number of civilizations, but that there might be that sort of number of habitable planets that might be Earth-like. We don't know whether being Earth-like necessarily means you evolve an intelligent species.
Of course,
It's done it once, but
yeah,
the only time.
could be, because the circumstances have to be perfectly right. Although we're assuming humanoid type carbon-based life forms, but there could be others out there that were created a completely different way.
Yep.
So that's the stuff of imagination at the moment, but it's a possibility, I suppose. And of course, we'll look like dills next week when a massive alien mothership sets itself down on top of the White House and
to rescue us all.
maybe. Gosh, thanks, Duncan. Thanks to everybody who sent in questions. Please send them in to us. I do have a bit of homework, sort of. We got a question twice now. I've received it from Mike in New York. Mike, you sent us a question in about black holes, an audio question. The whole guts of the question got cut off somehow. And so we got we got your preamble, then you started asking the question. Then there was about 5 hours of nothing, probably about 20 seconds. And then we heard you say goodbye. So we don't actually have the question. So if you'd like to send it again, please do. I don't know what happened there, but it's the internet. So that's what happened there. But Mike, would love to get that question so we can run with it. And any questions you want to send in via the Ask Me Anything tab at the top of our website, spacenutspodcast.com, spacenutspodcast.io. And don't forget to tell us who you are and where you're from. Thank you, Fred, as always. It's been a lot of fun.
Absolutely. It's great questions. Good to hear everybody's voice and nice to see their questions. Thank you.
Indeed. That's Professor Fred Watson, astronomer at large. And thanks to Hugh in the studio. Couldn't be with us today. He got stopped by border security and they realised he was an alien. He comes from New Zealand. It made sense. So he's been arrested. He might be back next week. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.